Okay, well, thank you so much, everyone. So I'm not going to spend too much time introducing myself since we've seen everyone, since you've met me. I think we're going to jump straight into presentations because I think that's the most sort of interesting part of this. So I think the first, if it's okay, we'll start with 360. Yeah, so the timing is right here. I can't see the timing. That is my timing. I think that's my 10 minutes. So maybe we can reset extra a little bit of time. Yeah, there we go.
Hello. Yeah. Hello, everyone. I'm Ruben, founder of Atom 360, and we have our teammates, KK and Rosma as well. So feel free to catch up with us. At Atom 360, we believe that healthcare should be an affordable necessity and not a privilege. Anything that we take up is on those lines. To start with, I'll just quickly start with a story. It's unfortunately a story that most of us have experienced or already know. Let's say someone who we know whose name is Mukesh. When Mukesh one day goes to has severe pain and he visits the doctor says it's an advanced stage of cancer. Because at that point in time, when the pain comes in, it's already stage 3, stage 4 of cancer. At this point in time, two things he could do. He could get treated and extend his life by another 5 years, or he could die like 9.6 million people who die every single year because of cancer. And this is the life story of millions of people happening every single year. And we as friends and family not just go through financial toxicity, but also the emotional pain of losing a loved one. Now, this is happening at a stage where, if you look at it, 80% of people in India come only when pain comes in, which is too late and we're not able to save them. In India alone, 10 people die per hour because of oral cancer. And a single hospitalization, 80% of the population don't even earn enough money to kind of pay for it. And we said, if this is the life story of millions of people, can we do something about it? And we try to find out what could be done. One of the things that a lot of doctors do is on a weekend, on a Sunday, they go to these villages and we do these screenings. But this is something that is not scalable, and we end up seeing majority of the population coming to you. And that's how we said we'll try something different, and we created Vericare. Primarily because smartphone penetration is higher than healthcare penetration in the world, we've taken this approach. Our solution is simple. We ask risk-based questions like, do you smoke? Do you drink? Do you chew tobacco? How long have you been doing it, and how often do you do it? And then we take 10 images of the oral cavity. You can see we have an overlay where it would guide anyone to kind of click these 10 different images in a standardized one. And then we kind of recommend the patient to go to the hospital. We can award a patent for that. Now, a majority of the people who chew tobacco, consume alcohol, and HPV-infected people are prone to oral cancer, but nonetheless, people above 30 years are meant to screen for this. Now, the problem is that in India, at least, the population that is actually screened for cancer is extremely low, though it has been recommended that most of these people screen. So that's how we've, so this is our solution, and intended customers, primarily if you look at it as a market, most of these solutions are taken by the government. We are also trying to come up with new ways or new policies that might need changes that could enable a new market opportunity to be opened up. So here, at this point in time, we are trying to validate the solution in collaboration with PORTENT and St. John's University here. So here, talking more about our study, it's on the early detection of oral cancer and OPNDs, primarily for the high-risk population and The goal is to be able to demonstrate that with a smartphone, which is accessible by anyone, which has at least 5 megapixel camera, anybody is able to screen for cancer. This would eventually make it more affordable and accessible to everyone. So as you can see, oral cancer is the second highest cause of mortality in India, and it's the sixth most common cancer in the world. And majority of the patients are coming too late. So our approach has been that how do we, 80% are coming too late, there is something wrong in the solutions or the approach that is taken, that people are doing. So the way we kind of differentiated ourselves is to make it more, so our solution is cheaper. So we said, if someone can afford a cigarette pack that causes cancer, we should be able to provide screening that is cheaper than that. So that's the approach that we've taken. We've worked hard on making it more user-friendly. A lot of other companies that have tried different approaches, and this is ours. So as part of the study, it's primarily to validate the accuracy of identifying these lesions. So this will be not just at the hospital where patients are going to too late, but we'll be going out and kind of screening people or kind of validating it as well. And how easy is it? Because this solution, only if it empowers a normal person to be able to screen, should be able to save these patients' lives. So it's important to also get insights on how we can improve the solution. Here you can see we've registered our algorithm as a Class C medical device. Now, majorly Class A, okay, the image is not looking very good. But the thing is that a Class C we have gone because the intended use is to identify these lesions, but we wanted anybody to be able to identify these lesions. So we have a model on the mobile that guides a person on how to click proper images, because a lot of people don't click proper images. So we've done a lot of work on deploying an AI model on the mobile. This is, I would say, is cutting edge, because at this point in time, operating systems are changing with AI becoming a foundation in the layer. And even then, we've been able to crack that code and work on it. So these are different lesions that we're able to pick up despite rotation, translation, scale invariance. So our timelines, these are the timelines, and we intend to get ISO 27001 HIPAA, GDPR, ISO 13485 certified also in the next couple of months. Now, this is an important collaboration because I think it would kind of independent validation is critical for us at this point to build credibility and adoption in the market. And Government of India has recognized that oral breast cancer are the three major cancers that every state needs to be screening. And we feel that this collaboration could help bring credibility to what we do. This is more about the team. We have experience from building and launching satellites to open source operating systems to developing apps. These are the awards and recognition and people who have supported us to get to where we are today. And we are grateful to them. That's pretty much it. And we have 3 minutes, so happy to take any questions.
This is pretty well. I just wanted to understand, how do you plan to integrate it into the team, into care?
Into dental care.
Within dental care.
Right. So here, at least in the US, you have this concept of annual dental checkup, but here it's not very prominent in India. So at this point in India, our strategy has at least been like, how do we get the governance and kind of we are integrating our solution into diagnostic apps. So our solution, we made it as an API and SDK, which means that with 3 lines of code, any healthcare app can integrate oral cancer screening within the solution. So most of the people here have some sort of app. So that's the approach that we are taking. So diagnostic companies in India, because it's a populous country, they could have the ability to go to the patient's house and then screen them as well with a multiple. So we're trying to integrate it into that as an entry into the market. So that's because India, we don't necessarily do annual dental checkup, which is kind of mandatory, or which we see in ERSs and what like that.
This one, I'm telling you, I'm going to go to the question, relax. And what is the nature of your data set? How you present it with different age groups? Each disease presentation might be different, and those different groups, and how representative is that data set? How close to the numbers that you presented?
Yeah. So the first thing is inside of the mouth generally is, I would say, relatively similar, but all these lesions are different. So we have data across the country. So we right from South India to the North India. So you have a lot of variations in representation, skin color, to a lot of facial features and all those things. And these data sets we've planned with our own taxonomy, where we've identified all these precancerous lesions and cancerous lesions. So we've clubbed the cancerous ones because visually they're similar. So we've kind of created one that is works well with AI visual imaging data set, and then we've essentially trained the algorithm.
Great job. What is the study design that you're trying to use to evaluate? A, B, lots of questions. B, North India, there is a huge proportion of illiterate population that uses that raw tobacco form, which in Hindi is called gutka. Do you consider using, or would you consider having a training component that educates individuals on the perils of this? There is a lobby that actually prevents, there is a huge lobby that is connected with politicians that sells these useless products. So that's two. That's the social part of it. And three, the Indian government has a lot of healthcare worker programs. So would you want to integrate that in also training programs before you launch this? Because that would help in update.
Right. So answering the first question on the study design. So the way we look at it is we wanted to validate this. Now, some of these lesions you could have a biopsy, which is the gold standard to combine. But some of these lesions you don't, because it's at a very OPMD, which is a potentially malignant disorder, we don't actually recommend them to do a biopsy. So what we decided was to have 3 doctors to look at it in a blinded manner and take a majority voting method to kind of take that as the gold standard, that we are not able to do that. Now, apart from this, we also have a dentist in the field because those images are captured by our BodyCare app, and the images are coming to the AM and then blinded to 3 other doctors. We also have on the field a dentist who will be looking at these patients directly, and he will be kind of noting down the details as well. So that's how we decided to go about the study design. The second part is a social element of it. We definitely agree. One of the things is we kind of positioned ourselves as a screening device. So it's affordable, cheaper than a cigarette, and it should be accessible to everybody. And then we bring them to a hospital where they could get diagnosed. You know what? One of the cases that we heard was one patient wanted to use our app. She was a servant, and the owner kind of read about her, so she kind of connected to us. And the thing was, the patient already went to the hospital, and the doctor confirmed it was cancer. And she's just looking for someone to tell that she doesn't have cancer because she cannot afford it. And so the basic details that there are schemes and governments for people below poverty line where you can get free treatment is even that a lot of people don't have. So that's why in our app we've added that details. But any connection that you can help us with, we'd like to do. So what we do is we give a report on the that it comes to whoever is having the smartphone. Currently, hospitals, when they do the screening, it comes to the volunteer who's kind of screening the patient. So generally, these patients, when they do the screening, they expect something out, right? So, but there we don't mention if it is leukoplakia or ectoplakia or cancers. We say a suspicious lesion found, and we recommend you to go to the hospital. And then we give a visual image of, without marking the lesions, just the dots, and here is where we've identified this lesion. Suspicious lesion found on the right in a cheek or left arm or something like that. And then we show these details. And then Yeah, because they expect something to be printed out, otherwise they are left hanging because they have something in the mouth with no idea about it. So they are expecting. So we just say suspicious lesion.
That's the so does this say that's what I think is they can the agents are recipient. So it's a little education determining the image is going to say suspicious features will say separation with the plakia, with the plakia, all premium versus actually in the sections. That's so how is the image long-term signal?
Right. So one of the things. Yeah, so what we essentially see is that you're right. So a lot of people, despite the advertisements and movie theaters or on the cigarette packet, and they don't want to know that they will have cancer. So, but what we also see is that screening is happening in India. Like let's say St. John's goes to the community and will do a screening. People do come because they don't know that they have pain yet. Because that's the stage 3, but they might have a leukoplakia or an infiltration in the mouth. And doctors do find such patients and they will bring them. So that's why we kind of integrate our solution into diagnostic companies that are already doing 100 tests, and this will just be 101 tests. So they're not very specifically, when they're doing the blood test, they're not specifically asking, I want a cancer test. It's like integrated into it, and then they're trying to push it into the market. So that's what currently we are doing. Because educating them is and convincing them is a big thing. So that means the whole startup, we don't know how to exactly crack that.
Thanks. So we will just to reemphasize, it's really very novel and really trying. So congratulations. I think what you're hearing from several people is not only that we have the value proposition, but to who is the title of the it's probably really to the person even use this unsupervised way. What is it going to be for sometimes who are familiar with this experience? If everyone is calling it up about who's the value proposition. So and that poses 2 challenges. One is that the body of value proposition that's going to be achieved, that's going to be efficient in terms of screening. But the other is that it's going to be effective in terms of getting early stage drugs. And there's huge amounts of issues. That raises 2 issues. One is that when these early stage lesions is going to be a health concern. We want to accept so that one can capture you can capture your cases of early lesions to be treatable. Getting that right is not going to be easy because even if you do the gold standard biopsy or whatever, it's not going to be easy. So something that these boxes on the right, you get 3 experts, is not necessarily something that they convince. Because it's one thing to get regulatory approval, it's another to convince ministries of health for to make that recommendations. I think the third is the issue of the psychosocial issues. So that's where you no longer think exactly many people are using this. Who's going to use this? I think maybe it needs to be clarified. much. Good. And we come back to we evaluate two medical devices. Study. So we across Africa we see great number of incidents, and it's worrying, especially among this younger population. We're seeing that 1 in 28 adults have diabetes, and of all this, we have about 34% that goes undiagnosed. And so, given the legacy challenges within the low and medium income families of access to care that varies from urban to rural, and also the human capacity to handle most of other healthcare challenges. And most of our programming has really been focused on HIV and infectious diseases. So where we have NCDs, we have a protein attachment. And so we had this very subtle tsunami that we're just waking up to. And so despite all these challenges, we know that the gold standard for the best practice of long-term management monitoring of diabetes is HbA1c. But even just the basic diagnostic of diabetes is rare. That is across the spectrum of society. So we have the infrastructure gaps, and because of these, there's need for decentralized access to care, especially diagnostics, to inform referral into care. So what we have done with support from PORTENT and guidance of Dr. Agri, we are conducting a study just to evaluate two medical devices. This is from Roche, for Lumira, and then one is from EKF. And the Lumira DX is a point of care. Then the collab from EKF is more like desktop kind of device, as you can see. And so in this study, it's a cross-sectional mixed method study where we're doing a prospective cross-sectional. And we have a quantitative arm and then qualitative arm. In the quantitative arm, we're enrolling 392 adults with type 2 diabetes. So each provides a venous sample and their routine care. And so during that visit, we check for 5 minutes of blood, venous sample, and we run it against the gold standard, but the reference standard in the central lab against 2 of the devices we evaluate, just to see the accuracy of these 2 point care devices, because within our context, most of the tests are centralized. And so the objective of this study is to evaluate the accuracy, but also how we can integrate point of health within each, especially for the rural settings. And in the qualitative arm, that is what we're trying to look at. We're conducting the semi-structured interviews with healthcare providers and patients, and we are guided by the technology acceptance model to assess device usability, acceptability, and how we can quickly integrate it within our existing workflows. And we shall be able to integrate these 2 methods to get a comprehensive understanding of how we can advocate for this in policy. So these are the devices we have. The other side we have the Lumira HP. It's using a single drop finger stick for venous blood, but in this case we're using venous blood. And you get the turnaround, the results come out under 5 minutes. And the good thing about it, it has built-in connectivity, and so you can synchronize with your existing electronic records without the need to print out paper and use results in between. The collab utilizes the baronet affinity chromatography, and then also returns results under 4 minutes, and with a precision of less than under 3%. And so they have different throughputs, but if you look at the overall objective is turnaround time for the results. So the patient will be able to get the results quickly, but again, we'll be able to evaluate it against the reference standard. So here, quantitatively, we are capturing all the different we have different aspects we're looking at quantitatively, and so we're going to be using the red cup, and then for the qualitative, that would be the interviews will be transcribed using in vivo, and then we shall be able to do the portfolio and understand people's perceptions about the tools. And so when we go to the statistical analysis quantitatively, so we're looking at diagnostic accuracy matrices for both devices with respect to the reference standard, specificity, along with ROC curves, and also I'd like to ask Dr. Agre to explain something about the blind ultima that we'll be using just to make sure that we are capturing two lessons for validation.
So the AnemiaPhone is going to see how the devices align with the standard and see if the variation low sugars or sugars and different. I mean, that's really we are trying to compare them the standard.
Yeah. So at the end of the study, we'll be able to integrate these two different efforts to understand how we can be missing on time. But be confident that we will be able to get the accurate results in remote settings. So at the end of the study, we anticipate that it will demonstrate the immediate and on-site HPA testing. The turnaround time for results will be quicker. We are trying to. There's a mandate for the Ministry of Health to decentralize access to diagnostics. Also, there's a national NCD agenda that our research will fits in that is trying to decentralize access to diagnostics. And the challenge within emerging markets for the case of Uganda is even device manufacturers do not know how to go into the market, how to integrate within for workflows, and we hope that because we're the best in that area and we have a research team that most of these aspects will be able to be addressed. And from this, our paper will be able to one policy, and we have our engagements with the ministry as stakeholders last time. So it will be easier for us at the end of the study to see how best we can scale up an adoption of point-of-care tests and also guide partners and manufacturers into how exactly to come into our market. And so the broader implication is that we really want to see how we can integrate tests. Most of our people is just analysis, and we have not been paying attention to point-of-care tests, even the tests that we do within clinical services are within centralized labs. And these can only be from within internal centers. So the turnaround time is in the rural areas of the lab sample terminal development is really
very nice work and very important work. I have a question about the interference of hemoglobin variants on A1C. Sickle cell disease, sickle cell trait are known to interfere with A1C results. Are you taking them into consideration in your study?
Yes, we are. I didn't include the inclusion and exclusion criteria, but as I said, the research we have within the study. So we are looking at, of course, muscular community type 2 diabetes. So other diseases that actually have a direct effect on HbA1c and sickle cell our females taken into consideration, and we want to see if the central lab gives the result, will the protocol tests also give the same result.
So actually, one of the reasons that we are testing these diagnoses is that we have developed outside that in a part of the world, 75% of us, I mean 25% so that's actually why we need to have it, especially why. So we shall actually have to do some extra tests and what so that we know our limits. But yes, and just Yeah, just a quick suggestion. In hemoglobin variant regions, such as hemoglobin variant screening and A1C diabetes screening should be done in parallel, otherwise they won't go. A1C tests, there is currently no A1C test that works if you have sickle cell trait or sickle cell disease. They will either overestimate or underestimate.
Yeah.
So even if you validate according to a reference standard will overestimate or underestimate. So your study might show that there's alignment, but overall, all the technologies are failing when it comes to sickle cell disease or sickle cell trait. So this is a major issue. This would be. Thank you.
And I think also some of we also took into consideration things like this. So now a robust, competent.
Is it possible? So I love these devices, but the problem is that are they going to be affordable? Like after validation, are they going to make it affordable for Uganda? Other companies, is there something in place? You might want to consider distribution so if you're collecting all of this data. So with when you collect data and you get all these endpoints, which we will see, you might also look at your socio-demographic variables and create risk prediction algorithms because that will help you validate the next device. Because the point of care devices for HbA1c are not that great. Like I'm talking about the non-technical kind. So just to sort of expand on your research program and how you inform the government.
Yeah.
Think sustainable.
And we have this as one of our objectives within the qualitative study, post evaluation. Something that we are very keen on to argue. But also, you point out something the predictive algorithm. You don't just study something you want so that you don't just this. Yeah.
I would like a definition to what criteria you're using for HbA1c. So
Yeah, so from the literature that we have by the doctors, current guidelines, only about 7% is considered well diabetes. So that's the literature that we use.
So what do you consider? So HbA1c levels and as a yes, no, HbA1c. Very much so I consider diabetes and national stage one. So there's a fair amount of information and it seems to be so consideration of capillary blood versus venous hemoglobinopathies, iron deficiency to consider. There's quite a lot of information as well. So,
Thank you so much. Sure, talk about this. I have to discuss it. So.
Hello, everyone. I'm going to present my research report in Dr. Erickson's lab on precocious sarcoma. So these are just some exemplary images of what precocious sarcoma might present in the clinic. As you can see, there's quite the heterogeneity between these patients, and these are all people that have been enrolled in our study for years. So just a little bit about Kaposi sarcoma. It leads to a very high mortality rate in sub-Saharan Africa. It's estimated that that mortality rate exceeds 40% in 2 years. And globally, there's about 34,000 new cases of KS each year. Almost 80% of these happening in sub-Saharan Africa. And then a couple of notes, the median age at diagnosis is under 40. So these are fairly young patients, and almost all of them are diagnosed at late stage T1 KS. So the current clinical practices to diagnose KS, they lead to poor accessibility and not great accuracy. So what's probably most common, from my understanding, is that patients will present to a clinic. Pathological diagnosis isn't necessarily available, so a clinical diagnosis will be made based on how the patients present. This only leads to a 77% predictive value. And even if pathology is available, the sensitivity and specificity of 72 and 84% are respectively. So it's a difficult thing to diagnose and diagnose accurately. So what was hypothesized is that since Kaposi sarcoma is necessarily caused by a herpes virus, KSHV, we could diagnose Kaposi sarcoma by detecting KSHV in lesional biopsies. So the scheme that has been so what we do is we collect a biopsy and we bisect that biopsy, so some of it we would routine pathology, and then we do a DNA extraction, and then we detect if there's any KSHV DNA in that biopsy. This is important because KSHV is associated with all KS cases, so it is a necessary cause, and this allows us to get high specificity, which wouldn't be possible with just a serology test, as upwards of 40% of the population would be HB. So to do this study, the lab invented and developed the Tiny device. Tiny is a device for running lamp. And as you can see here, it is quite small. And it can be powered off. The heating element can be powered by either a flame, solar power, or electricity if that's available. And these tiny devices were manufactured and distributed through sub-Saharan Africa with the Infectious Diseases Institution in the flagship location. So over the years, we have our training set and we've done a validation set since. So in our first set of patients with 491, we showed a sensitivity and specificity of 97% and 92%. And then our temporal validation with a consecutively acquired set of patient samples, we see similar sensitivity and specificity with 95 and 90%. So moving forward, what we're working on now in terms of the innovation is how can we speed this up? And if you can imagine, the difficulty here is in getting the DNA out of that biopsy. Given seroprevalence of KSHV, the biopsy is a necessary step for this, and that DNA extraction is the least point of return rate upon this process. So what we hypothesized is that we could simplify this down and get a small piece of that biopsy and treat it more like a liquid biopsy, subjecting it to a more rapid DNA extraction or even something that was direct to PCR. So this is what we've come up with. I'll go over these briefly. We call this slicer. This is how we're manually processing the biopsy before a quick compound DNA extraction before we do the DNA test down. So slicer, we made these to be single use. We're enrolling hundreds of patients, so they needed to be simple to put together, cheap to make, and easy to assemble. Essentially, it's two razor blades in parallel with the goal of taking a thin slice down the center of the biopsy. This is important because with KISS, the lesions aren't heterogeneous or are not homogeneously infected with KSHV. So we hypothesized that giving a slice in the middle would more replicate what we see with the histopathology, where you'd get a good sample biopsy, and then the remaining half cylinders out of slicer, we're using them for routine pathology, and then we're also doing a full DNA extraction as a comparison. So we've probably sent upwards of 300 to the IDI thus far, with no incidents. And I'll present a little bit of the data that we've had with these. So we finished 128 patient biopsy samples using slicer and rapid whole chop relay extraction. Compared to D&EZ, we see a 97% agreement. So this has allowed us to take a process that typically takes over a day, at least an overnight incubation for the DNA extraction, and we can condense it down to results within 2 hours from biopsy to event result. And then for the up to 128, we don't have pathology data for all of them yet. For those first 27, we do see that any of the samples are completely void of KSHV DNA or KS absent by pathology, and with the KS present cases, all of them showed KSHV DNA. So what we're working on now is we're trying to move from more of just the laboratory to what we just take to move to the market, is develop a business case for sarcoma diagnostics. Like I said, there's 34,000 cases a year. In the grand scheme of things, this isn't a ton, but we're trying to put together the economic benefits of widespread testing. As I said, this cancer is typically diagnosed when people are less than 30 years of age, and they're typically diagnosed at late stage disease. So with implementing a rapid diagnostic like this, we're hoping that we can make the case that we'll diagnose patients at an earlier stage. They'll be easier to treat, have a longer lifespan, and not only easier to treat, but cheaper to treat. So this is what we're going to be trying to, test these hypotheses as we move forward. So our next steps, needs, and goals. We need to finish our validation of KS complete, and diagnostic is a holistic approach. And then we really need to test our business proposal. Like we will indeed count stage KS, and that those will have those socioeconomic benefits that I listed before. And then we're looking at what kind of partnerships we'll be able to make to bring that KS assay to the. Thank you.
Sure, the first question is what percent of these patients have everything?
So the question here, if you
Yeah, so technically, I think I would say about I'm trying to about a quarter of the patients we see 75% start with the skin. In fact, for us, we do the reverse. I can go in and check the few number, but to answer your question, because it's easier to get tissue on the skin as opposed to the mouth, my nurses and clinical staff do the reverse. We go for the skin here because the surface is easier and all. But it's possible you can go in and see, because we check the patient, you can go in and see how many people so actually have them. So that's one. But I suspect it's about 25 so. The reason I say that, having obtained the tissue, the process can check off the cell. The challenge is that until I get the tissue, I will not be able to use the DNA process unless we kind of things. I don't know if I've answered the question, but it's sort of it's a yes, but I have to start with tissue. And in our setting, it's a bit harder to get tissue from the mouth because you need an oral sample themselves. But if I have a nurse or somebody that can use the wait.
say this. Different stage.
We do it. That's why I need to check my data, but I'm not for sure that the mistake. So,
Second one. So the country is that's the same question. We're doing it in places they do it. But we're doing it.
Maybe I will just mention something. One of the things that we don't talk about within Uganda is the anchor of our healthcare system is what we call community workers. Community healthcare workers. These are best within communities, CHWs. So what the ministry is trying to do and what partners are trying to do is we have them on board for missionary research. IDI has a principle that we have the community advisory board for all our research. And one of the key people that we have as a core component of our community advisory board for all our research and implementation is a healthcare work, community healthcare work. The research we're doing right now has to speak to their technical training for community able to have these within their communities when we decentralize access so that they can be able to screen and refer to care at that point. So we're trying to empower them intermediate. So that's what we're trying to do, at least for idea.
what we didn't say with this story is that actually the development of this particular device has taken what, since 10 years? 10 years or so. And we started off by going to Google or develop and change. But one of the questions you asked is thinking about the end user. Begin is one, but we've done campaigns of education. But one of the bottlenecks you always find is that, okay, make me aware, then what? What can I do? In other words, when I tell a clinician to find something in the skin, what? I should be able to give him a simple punch needle, which is like the pen, the gold, very not the skin, take tissue, and then you move that. But there's a whole chain of active things we get to potential. It's never seen thing that's sickle. We have videos, we have radio commercials, we have all sorts of education campaigns. But it's at the point where we're like, okay, I've done this side, we need to help the healthcare workers to manage the flood of the it's almost a story of self-defense, and you say, you're screaming, and then the avalanche comes to the clinic, and they're like, oh, what can we do? So we kind of have to think, as we develop this public campaigns, what tools they follow, and sort of think about the process all the way through.
No, it's just about this probable options.
whole discussion. Just correct me if I'm wrong, in some way the need to go it's really low. So the key issue is that early detection. What you want to do is localized lesions. Systemically, then don't you hearing completely different issue of we're going to have chemotherapy and there was an emphasis that's leaving and it's a whole, so the clinical issues are very, very different. I think, again, I mean, some people are looking, why making them now, but really, when you want to get off the root cause, which is those are the problems. So anyway, and just something just to think about. Some of the things in the business plan, we took some very strong assumptions that you may want us to review again. Well, this thing.
Okay, so first of all, I want to thank the first presenter for saving me time. I don't have to go through the first part of this slide, especially in this audience that knows what all cancers are. So the epicenter for that disease, our in the entire world. But the gold standard for this malady is the scalpel biopsy followed by pathology review. Its limitations is that it's really costly. In the United States, it's estimated to be somewhere between $1,500 to $3,500 for a biopsy and pathology review included, depending on what institute, what medical center we're using. So, and it's invasive, it's associated with increased patient morbidity. And I must say that primarily in low to middle income countries, the pathology reviews are sometimes imprecise and misreported. And if you need repeated assessments, it's not feasible to do biopsies over a given period of time. And interestingly enough, at least in the West, and in the United States particularly, clinicians tend to overbiopsy, which means that in the end, greater than 90% of those biopsies result in non-OSCC or squamous cell carcinoma. That's a good thing. But think about that 90% of people who are stressed, cost issue, the time required to determine yes or no. If we could find a way to lower that number, that would be very beneficial. So the unmet need is for rapid, objective, non-invasive, low-cost detection of oral cancer and potentially serial monitoring of the precancerous lesions. That's a very, very important issue in this regard. And potentially it can act as an adjunctive tool to assist the clinician in determining who actually needs a biopsy. So I'm dating myself because this goes back to the 2000s, early 2000s, when I was an assistant professor at the University of Washington. And I was always intrigued by these really benign lesions that we all are aware of. We do it on a regular basis. We bite our tongue, we bite our cheek, we eat hot soup and burn our palates. And oftentimes, even after a local anesthetic by a dentist, you can get erosive or ulcerated kind of situations, as you can see down below. And I was always intrigued by these lesions occurring in a very septic environment. You got over 700 species of bacteria, you got fungi, you got viruses, and all of them are trying to penetrate into this tissue, into the wound itself, and it will heal really, really quickly. And that led us to discover that these lesions in the periphery of these lesions, small antimicrobial peptides are produced. And they're produced, they're preformed and they're rapidly released. They're antimicrobial because they're cationic in nature. The membrane of bacteria is negatively charged. It gives an electrostatic interaction, and that leads to the pore formations in the membranes of the bacteria, eventually the death of those bacteria. So we discovered multiple different forms of these antimicrobial peptides that became a family of peptides referred to as beta defensins, produced exclusively in epithelial cells. Two, which I'm bringing to your attention for today's presentation, is human beta defensin 2 and human beta defensin 3. They are similar in certain aspects, structurally, but they're really different in terms of certain aspects of biology. HBD2 is regulated through inflammation. There's a transcription factor referred to as nucleofactor kappa B, NF-kappa B, at the heart of inflammation, which promotes chemokine and cytokine production. HBD3, interestingly enough, also an antimicrobial peptide, is regulated through the process of cellular proliferation, epithelial cell proliferation through epidermal growth factor receptor on the surface of the cell that's activated to promote proliferation and movement. That's very important in wound healing. Okay, so keep those two concepts in mind as I go through this. So we started asking the question, well, if HBD3 is regulated through this process of cellular proliferation, how will it express itself in the context of early stage cancer, where there's a lot of proliferation, or in the context of precancerous lesions, where there's also proliferation? So we started looking at tissue. And what you see here is an example of what we saw routinely. What you're seeing here is the floor of the mouth, and this is the mucosa, the floor of the mouth, where the pink color, this is immunofluorescence. So this is the pink color represents human beta defensin 3. The green represents human beta defensin 2. And notice how they're separated. The HBD3 is primarily expressed in the basal keratinocyte region of that oral mucosa. That's where the stem cells are. That's where a lot of proliferation is occurring. And as the cell ascends from the basal mucosa through the spinous layer, granular layer, and finally the keratinized layer where it exfoliates, it goes from highly proliferative situation to a less proliferative but more differentiated state. So the green is representative of cells that are differentiated and no longer proliferating. And that's under normal conditions. But then what happens is that the transition, as you see here down below, from a normal state to a carcinoma in situ state leads us to see that indeed there's a tremendous amount of HBD3 expression with very little HBD2 expression. Okay, and that confirms or supports the hypothesis that HBD3 is going to be more expressed because it's regulated through the process of EGFR that I referred to before. And that's the same process that occurs in the early stage of carcinoma in situ. All right. Now, what you're seeing above is confirmation of proliferation through PCNA in conjunction with HBD3. Red and green turns orange, and there's a lot of orange going on in the tumor area. And there's also a lot of orange going on in the normal area that I showed you before. And then finally, beta-catenin is a marker for cancer. And when it translocates from the cytoplasm into the nucleus, you see these opaque kinds of nuclei, as you can see with the white arrows, when compared to the clear nuclei that appear in the normal area. So that's telling us that this is cancerous, but it's stage 0. It's the earliest stage of the disease. And so that led us to think, well, what if we were going to cytobrush the lesion? And then you got to have an exposed lesion. What if you could cytobrush that lesion and look at the ratio of 3:2 lesion compared to the ratio of 3:2 on the contralateral normal site? So now the patient is their own control. All right. And that led us into a long-winded story, which was stopped by the pandemic. So we couldn't get this thing finished in time. So last year it was published. in cell reports medicine, where indeed we conducted proof of principle studies, discovery, and independent validation in 3 different institutions to demonstrate the ability through an ELISA process where we took cells from the lesion site, a suspicious lesion site, and compared it to the control normal site. So it was a ratio of 3:2 lesion over the ratio of 3:2 normal, which created a beta defensin index, or BDI. And as you can see down here, now this is OD readings, optical density readings, because this was done in an ELISA form. Well, imagine if we were then to transition that from ELISA into a point of care device, lateral flow. And that's where we're headed with this. Point of care device for early detection. The biomarker based on the ratio of 2 proteins, HBD2 and 3, taken from the lesion and contralateral site in the same patient. It can be performed in any dental clinic as part of oral health checkups for early detection. And clearly it can be performed, hopefully, I'll learn more about this during the next couple of days, in the field. It should be able to be performed in the field. Provides rapid results in 15 minutes using handheld device. And this is the short of it in terms of the discovery cohort and the validation cohort done afterwards, with the RSC curves demonstrating a threshold of 1.25. Anything above that was deemed cancerous. Anything below that was deemed not. Now, I point to your attention, the one, is there a way to? Oh, this. So you see this one right here? We found out after the fact that that was an error, technical error by the person running the ELISA. So this is very, very important. The Achilles heel to this is to make certain that you're doing the lesion site over the contralateral site in order to get the BDI. Well, this was done in reverse. And so that was the only reason why the sensitivity was not 100%. The specificity was 84 or 83%, which means a 17% false positive rate, which is not exceptionally bad. It's not all that great, but we found out why. When you see these, right these through here, these blew up here. They were precancerous lesions. So now we know that what the BDI is telling us is not just cancer, but also precancerous lesions, which is expected because in the dysplastic lesion state, you're going to see proliferating cells, a lot more than even in the contralateral cell. So from a clinician's perspective, what this is telling us is the patient with a BDI that's above 1.25 is going to be either cancer or precancer. If it's precancer, it tells the clinician, hey, I've got to follow this because this could be very, very important. And so before I give the rest to Umar, I just wanted to summarize that this rapid test, it's non-invasive, it's low cost, and I'll get to that in a second. Each subject is their own control, which is very, very important. It relies on 2 analytes and not 1. The sample from the normal and lesion site can be analyzed simultaneously, thus minimizing inter-assay variability. It detects cancer in questionable lesions purportedly, so we develop this thing within a 15-minute period, provides an objective quantitative measure, which imaging does not, because with the Visalite and Bellscope that was mentioned earlier, the imaging story is very subjective. The clinician has a learning curve in order to learn what he or she is seeing. So that this doesn't require that. It's all objective. And it's going to be substantially less expensive than biopsy followed by pathology review. We already know that less than 1/10 of the cost of a biopsy plus pathology review is what we're looking at in the West. Less than about $100. And clearly in LMICs, that's going to be substantially less than that, based on what I'm being told. And I think that's when I will transfer this to you.
I would like to just quickly summarize what we have done with the PORTENT support so far. As you have seen, we have done quite a bit of clinical validation in independent and multiple sites in the ELISA version of this assay. With PORTENT support, we wanted to develop the first prototypes of a fluorescent immunoassay that can perform this test at the point of care. And we have achieved that. And now we are working on analytical validation of the assay in comparing the fluorescent immunoassay rapid tests with the ELISA, as well as clinical validation in comparison to scalpel biopsy, which is the gold standard. We have actually made prototypes. We have brought some with us, and you will be able to see them in the demonstration. So here are packaged prototypes of the fluorescent immunoassays that we were able to achieve with the PORTENT support. And I will show you some the working principle of the assay and also some preliminary results. So the test essentially has, as you have heard from Aaron, we rely on HBD2 and HBD3 levels and their ratios. So we have two lines that are indicative of the HBD2 and HBD3 levels in a cytobri sample that we collect. So we essentially measure those the intensity levels, fluorescent intensity level of those two lines, and we have to perform two separate lanes for the control and the lesion side. That's why we have two tests here, as you can see in my hand. And then we take the ratio. Everything happens automatically in a portable reader. And we are actually partnering with one of our companies, Himex Health and Himex DX of India. And they already have a reader that can read these tests. And this reader is currently available in primary health clinics and health and wellness centers throughout India. So the technology is made in India, distributed in India. It's already available. All we need to do is make these cartridges and then provide them so that they can perform screening for oral cancer lesions as early as possible in those locations. So our preliminary results, since we don't have much time, I'll just show you a few examples. In the analytical validation with recombinant HBD2, HBD3s, test works, we can detect the levels, quantify. We also perform tests with real cytobri samples with patients and with subjects, and we can detect the HBD2, HBD3 levels very accurately using the Gazelle platform. You will be able to see the demo of the Gazelle platform and how the test works on the Gazelle platform in the coming days. So I won't go into the details of that. But clinical validation is extremely important. We have actually established collaborations in the northern part of India, where oral cancer cases are highly prevalent due to betel nut chewing, tobacco chewing. We have established a collaboration with AIMS Bhopal in Madhya Pradesh. We can actually see some pictures and a news article about that. And we also have clinical validation sites in the United States, in Cleveland and in Miami. So we are very close to providing these test cartridges to them, thousands of them, so that they can actually perform these clinical validation. And this was all thanks to PORTENT support. And I would like to thank again to the organizers and providing us the opportunity to present and also supporting the project in very much.
Oh, yeah. He doesn't, I know where you're going. Met a tremendous number of refugees from Southeast Asia, Pakistan, Bangladesh, India, to the ASEAN countries, and there is a tremendous amount of Europeans in this. But with the new administration, they cut it out. And I couldn't work with that. So we're doing a big study in the United States where multiple different pathologists are involved.
Hello, everyone. I hope I'm not the person between you and lunch. Good. All right. So, hi, everyone. My name is Antara Ganguly. Let me reintroduce myself. I'm a postdoctoral research associate at the Cornell Joan Klein Jacobs Center for Precision Nutrition and Health. Like everyone else, we are also year 2 of the PORTENT funding. I'm going to talk about AnemiaPhone, which is a point of care diagnostic device that we've developed for quantitative assessment of iron status at the point of care. So before I begin, I would like to introduce you all to our team, starting with the co-directors, Dr. Julia Finkelstein, Dr. David Erickson, and our founding director, Dr. Saurabh Mehta, research associate Balaji Srinivasan, and then myself. So before going into the POCDX solution, let's talk about the public health problem that we've been trying to solve, which is the iron deficiency anemia. As we all know, iron deficiency anemia is the most common nutritional deficiency. It affects about 2 billion people worldwide. And our goal was through this project, AnemiaPhone, to contribute towards the 2025 World Health Assembly target to achieve a reduction, 50% reduction of anemia in WRA, that is the women of reproductive age. So as we all know, anemia is a major issue. It causes impaired growth and development, multiple cognitive deficits and defects, impaired work productivity, and also an overall decline in the quality of life. So our solution was to build something that is really usable at the point of care, looking at LMICs as our target audience. So I agree with the discussions we just had in the previous presentation that we have to build something which is actually fully deployable, and is actionable so that you know what you do with the results, and also have a compact form factor, and to truly be a point of care diagnostic device. So this is what the AnemiaPhone looks like, or how we run the test. So basically you collect the finger prick sample, that is capillary blood, take a drop of blood around 50 microliters, drop it in the test strip, and then there's a tube reader, which is basically the reader which quantifies the out. And then the reason it's called an AnemiaPhone, and I like to address it right here because everyone is keeps asking me why is it called phone. It can potentially be used as we had some very successful parent technologies, Nutrifone, Feverphone. So we decided to run with the name. And also, basically, we can also potentially use it and interface it with mobile app or with smartphones. We've done it in the past with different projects. Just wanted to get it out of the way. So what is the AnemiaPhone? It's basically a lateral flow test. I'm not going to go into the details of the lateral flow test because it has been beautifully described in the previous presentation. But essentially, our test just has a test line and a control line. And there are two components to the AnemiaPhone. There is a disposable one-time use test strip, and then there is a reusable reader. So the reader is the small little compact tube with a very small form factor, perfect for field settings, for community, to be used with community health work. So yes, this has a test line and a control line. The control line is basically going to tell you whether the test is valid or not. If you don't see a control line, don't use that test, throw that away. Take a different test and start over. And the test line is basically telling you, the presence of test line tells you whether or not you have anemia. So what we are specifically focused on in the AnemiaPhone in the current version is using ferritin as the biomarker. So the test line intensity is basically directly proportional to the concentration of ferritin, which is present in the sample that we're testing. And since it's a lateral flow test, you just drop the sample, which is the blood sample, which wicks through the test strip laterally, and then you get a test line and a control line, and it's a simple sandwich assay. So again, if some of you are not so familiar with sandwich assays, basically the analyte of interest, which is ferritin, gets sandwiched between the test line antibody, which is the capture antibody, very specific to ferritin, and it gets sandwiched between a detection antibody, which is labeled with a reporter, and an AnemiaPhone. The reporter is the bone marrow. And this is how the transduction happens. So the way the cube reader measures or quantifies this test is that it scans through the entire window of the test strip. I don't know if you can see it, but there's a small window, like a typical lateral flow test. And you can see the control line of the test line. It scans through the window, identifies the peaks corresponding to the test line and the control line, and then gives out the ratio of the test line and the control line, which is the T/C ratio. And then this information is transduced into the concentration of ferritin. So depending on the population that we are trying to test for, we run a calibration curve. And based on the calibration curve, we get a function which is programmed into the cube reader, and that is fed into an RFID card, which communicates to the cube. So let's talk about the milestones that we achieved. So our goal was to develop, validate, and scale up the AnemiaPhone technology. So we have successfully developed the prototypes for lateral flow tests for serum ferritin, and we've also individually developed prototypes for STFR and CRP, and also we have publications for those projects. The second thing was to validate and test the archived clinical samples from our CDC-supported biorepository field site. We have also achieved a major milestone, which was the independent validation in archived samples in India. And then we are very happy to report that we've successfully transferred this technology to a scale of a public health impact in India. And now let's look at the data. All right, so let's look at the data. So we started with, after doing the proof of concept and proof of feasibility, we started with the optimization at the point of manufacturing. So we started with simple contrite samples, which is spiking ferritin into buffer samples. And then so as you can see from the first figure, that we got a very good dose-dependent response with a high R-square value of 0.96. This gave us the confidence to move to real serum samples. So the figure below on the left shows you the calibration dose response curve for serum ferritin in real serum. And as you can see, we got a very good linear dose-dependent response for that. We also did some repeatability tests. This was with limited samples, but as you can see, the coefficient of variation, which is what we use to ensure repeatability, throughout the dynamic range was well within 20%, which is the limit set by CLSI. So once we did this, we manufactured a bunch of tests and shipped them to our partner site in India at the Indian Council of Medical Research, NIN, National Institute of Nutrition in Hyderabad. And then we also just redid the calibration curve just to optimize it or adapt it to the local context. So this is the calibration curve from that. So like a typical calibration curve, the y-axis is the T/C ratio, the x-axis is the serum ferritin. And as you can see, locally, we got the R-square value of 0.93. Next, we also wanted to test the performance of our point of care diagnostic with the lab standard, which is the Roche. And we use Roche Cobas as the reference method. And figure A shows you that there was no statistically significant difference found between the reference method and our point of care diagnostic. We also did bland Altman analyses to compare both the methods. You can see there was a very high agreement between both the methods, the reference and our point of care diagnostic. And figure C shows the correlation, shows that the point of care diagnostic method is highly correlated with the lab stand. We also did some diagnostic test accuracy evaluation, and we got a sensitivity greater than 99% and a specificity of nearly 91% and an accuracy of 94%. And like I mentioned, we are very happy to let you all know that this was well received by the government of India. It's actually going to be deployed. So we've transferred the technology to ICMR. Cornell has licensed it free of cost. And the success story was widely circulated or widely available in the national and international media. And then ICMR and IN had also invited expression of interest to identify manufacturing partners for scaling this up and taking it and rolling it out to different states for it. So I think they have identified the manufacturers and are actually going to do. So it takes a village, since it's a lightning job and name everyone, but we are very grateful to PORTENT for the funding for allowing us to do this. And thank you, everyone.
Okay. Thanks for a nice presentation. You alluded to C-reactive protein and cell containing receptor. Is that to control for the inflammatory state? Is that going to get incorporated somehow?
So our end goal is to multiplex these three biomarkers. So serum ferritin, STFR for iron deficiency, and then CRP for infection, to understand, to sort of delineate within whether the anemia is due to nutritional causes or due to infection. We haven't, so that is the end goal. The work that I've shown here is just serum ferritin, but we've also done this independently, not multiplex, but independently in other. Yeah, that's the end goal. Any other questions?
Good morning, everyone. I'm Shiv. Kripa Gupta Yadire, joining you all virtually due to travel-related delays. Apologies in advance for any sound quality issues as I'm recording this in an airport. Today, on behalf of our team at McGill, I am excited to share our vision for Finexa, a single-visit test and treat platform for sexually transmitted infections or STIs and their antimicrobial resistance or AMR profiling. Every day, more than 1 million cases of Neisseria gonorrhea, NG, and chlamydia, trachomatis, CTR infections are recorded worldwide. The even more concerning trend is antimicrobial resistance in these pathogens is rising at an alarming rate, creating a $16 billion annual economic burden. Yet, today's diagnostic workflow can take 3 days or more, delaying effective treatments. In short, clinicians need a way to identify the pathogen and its resistance pattern during the first visit, so patients can walk out with the right therapy right away. At Finexa, we want to introduce something called a single visit test and treat approach. Finexa brings the lab to the clinic in a compact, automated cassette and reader system. The cassette handles sample prep, reagent mixing, incubation, and filtration, all without a trained technologist. The benchtop reader performs signal transduction, analyzes the data with our machine learning pipeline, and displays results on a secure dashboard. With a minute scale sample to answer time, the user just loads the urine or swab samples, insert the cassette, and the system delivers pathogen identification plus a multiplexed drug susceptibility profile before the patient leaves. Thanks to this streamlined process, Phoenix offers a range of advantages, including automation, multiplexing, simplicity. In addition to this, we incorporate design considerations to closely follow the TPP guidelines. At the core of Phoenexa is our patent-pending microfluidic and nanoplasmonic platform for minute-scale nucleic acid amplification detection. When exposed to radiation, the nanoplasmonic phenomena accelerates isothermal nucleic acid amplification assays by more than tenfold, creating a quantifiable optical readout that can be interpreted to identify and prescribe right antibiotics at the right dosage. The research has garnered attention from reputed journals in the field like Nature Nanotechnology. Over the course of past few months, we managed to go from a lab prototype on your left to a ISO-certified medical Mark 1 device on your right. Our goal is to iterate on this Mark 1 device until we reach an MVP via rigorous user feedback, real-world testing, and scaling. Really, the strength of the technology is its versatility. Starting off with COVID, we were able to demonstrate strong correlation with qPCR in 33 COVID positive biobank samples. Phoenexa prototypes have also demonstrated strong metrics for UTI and associated AMR determination. This includes 100% specificity across 34 UTI bacterial strains and accurate AMR determination in 53 clinical urine cultures at the McGill University Health Center. We show a strong correlation of Phoenexa with standard laboratory techniques. As you can see on your right, we have a correlation plot with qPCR for DNA copies using qPCR and Phoenexa. And we also have a breakdown of infections detected in UTIs where we were able to accurately identify several different species and speciation and corresponding AMR profile. The research itself of Phoenexa kicked off in 2019. Fast forward to 2021, we established the foundational R&D and provisional patent. We started the development in 2022 towards ISO-certified MVP and on track, and we are on track for Series 1 and Series 2 clinical testing by 2026. Our goal is to iterate on the ISO-certified MVP as we go through these clinical testing procedures. We also anticipate scale-up, regulatory clearance, and widespread deployment by 2030. Why does bringing Phoenexa to market matter to you all or to PORTENT itself? For one, our solution can make patients' disease progressions more manageable, help delivering treatments in a personalized fashion and in a timely fashion. It can help healthcare providers take the right decision with confidence and also save Canadian and US payers around $5 million in missed treatment costs. It can also save 90% of personal hands-on time and enable public health agencies to curb AMR at its roots. The initial purchase of Phoenexa comes with a benchtop automation and analyzer unit, while the disposable single-use cartridge serves as the recurring purchase, each at an average cost of $10. Our next goal is to raise around $1 to $2 million in non-dilutive grant and angel rounds to complete our Series 1 and Series 2 clinical validation and finalize the FDA 510(k) dossier. Uh, and the goal for the future would be to have a Series A round to reach 100 customers and begin to big scale up production of the technology. In conclusion, our interdisciplinary team at McGill is supported by experts in microfluidics, clinical microbiology, and health economics plus commercialization. Partners experienced in ISO 13485 manufacturing and global distribution. And thanks to the PORTENT Center, we had the opportunity to complete the lab to market program, which was insightful, and it helped us connect with a lot of great mentors relevant to our future plans. Let's tackle AMR before it's too late. We invite researchers, investors, public health leaders, and clinical partners to join us in bringing Phenexa to every clinic where rapid targeted STI therapy can save lives. Excited to meet you all in person at SJRI in the beautiful Bengaluru. Thank you. Good morning, everyone. I'm Shripad Gupta, joining.
I know it's lunch break, but I'll try to be quick and in the meantime, also convey what we have done. This was a study which was undertaken by SJRI and a company called MolBio, who have been in the diagnostic space for some time and have introduced tests for multiple infectious diseases. And they've also developed a testing modality for malaria, for which we were the clinical partners who validated their platform. Just to give you an overview, we know that malaria is a huge problem in India, especially in certain pockets. And India is very ambitious in wanting to eliminate malaria by 2030. And the challenges are, technically demanding diagnostic tools like PS, which require extremely trained microscopists, and RDT, which is, although very good and cheap, is not really truly sensitive or specific in certain aspects. So here what we have tried to do is clinically evaluate the TrueNat malaria platform for diagnosis, especially of submicroscopic malaria in field conditions, and to try and obtain results which will be able to help us get regulatory approval for scaling of these tests and look for commercialization copy of the same. So to give you an overview of this TrueNat, it is a lightweight, portable RT-PCR machine, which is on a chip, basically. So there is a universal PCR PET device, which will help us to prepare the sample and then load it onto this chip, which will then give a readout on the platform. The good part about this is that this instrument is already in multiple centers in India, which are doing tests mainly for tuberculosis. And we are trying to implement these for the same platform to diagnose and identify malaria. So this is the same thing. And so what we have tried to do is look at this clinical validation, for which we have identified 500 samples, which was discussion in the first session. The 250 positive samples, which included various combinations, 90 of PD, 90 of PA, and 70 of the mixed infection, and 250 negative samples. So what we did was obtain consent, collected the sample for testing. That is, whole blood is required for this particular platform, and simultaneously ran both the tests if they've asked for PS to also reconfirm by RTT and vice versa. And whatever was mismatched by the TrueNat platform, either the RTT or the peripheral smear, we ran a tiebreaker test using another molecular platform, the alpha. So these were the site visits. I already talked to you about was led by Sister Dr. Scoring, Dr. Sister Aquinas, runs the Swastika Raj Community Health Center in an endemic area of malaria in India, a very impoverished district and lacking in basic healthcare. So the device can be even set up there. So that's the beauty of this device. And so we went there. We ourselves looked at what's the kind of population that they were serving. And we also trained those people in using these devices and interpreting the results, obtaining relevant clinical history and also data. So what we saw, just a quick run through of what we could achieve in this year. So we could recruit all the 500 samples which we promised the important study. And if we look at the numbers, if you see that there is a distribution of different kinds of possibilities, what was there, which I compared it to different detail. The age group was the maximum, which was in the outdoor category, that is 90 to 30, although cases range from 1 year to greater than 60 years. So what is interesting here is the peripheral smear, which we took as the gold standard, was compared to the TrueNat as well as the RDT. In the TrueNat, compared to the peripheral smear, there was good agreement between the species, Vivax, falciparum. There was the mismatch was when it came to mixed infections and many of the negatives being picked up as positive by the. So what we feel is, since it's a molecular platform, the sensitivity of this is definitely going to be higher. And what we saw was that was what it is. And we were able to pick up at least 24 more number of positives compared to the peripheral smear. And the sensitivity specificity of the TrueNat versus RDT. Sensitivity was 99%, specificity of 90. That's because there was a misclassification of species as well as more number of negatives being picked up as positive by the TrueNat, and the accuracy being 90%. So if we look at each of these discordant ones, the 54 of the discordant samples, what we saw was that in most of them, when there were individual species, we didn't have a problem. But when there was mixed, some of them were picked up as individually as falciparum, some individually as Vivax. This has implication in treatment. That was why it is important to differentiate the two. Negatives were the ones which were the actual challenge, and they were picked up much better compared to the peripheral smear. And when we had a tiebreaker test, the TrueNat appeared to have 7 false positives. That means still that Altona said whatever the PS was the truth. And we had 1 false negative. And that means what we picked up as positive, what we picked up as negative, it said it as positive or the other. So that was one problem that we had. We couldn't explain. Probably we'll have to do a genomic assay to see what the actual. So when we compared the TrueNat and RDT as well, it had a sensitivity of 99%, specificity of 81, and an accuracy of 89. So these are some of the peripheral smears. We learned a lot and went to the field there and actually. And in terms of timelines, I think we finished the clinical validation. We're going towards presenting the state of the government to see if this can be deployed in areas where there is a high suspicion of malaria, but microscopy and RDT picking them as negative, and also where the species has been developed. So the limitation of TrueNat is that although it is, you can place it in very peripheral settings, unlike the RDT, you can take it door to door. But whenever there is a high clinical suspicion of people having fevers and there is malaria in the mind, you could use this as a platform to actually use it as a test, and therefore bringing more people in the ambit of treatment as well as the ambitious target of eliminating malaria. Yeah, I mean, that's what the government wants to do. We don't know that is correct. That is why, since it's a molecular platform, we are expecting it to overdo the PS. Yeah, so since we had no idea of what is the actual gold standard, we use what is currently used as gold standard in the program as PS, because anything which comes in the program is taken against PS. That is why we used. Absolutely, absolutely. Just like how tuberculosis, culture is still the gold standard, and gene expert outperforms that, but we still call it as false positives.
Just, from malaria as well. So, having the malaria in the blood doesn't mean something. So, did you check the clinical side?
Yes, all of these were symptomatic.
Symptomatic.
Yes, we
So
haven't
you
taken
didn't
them.
have a symptom.
We didn't recruit the asymptomatic. So
Okay.
those who came with fever or high suspicion of malaria is whom we employ this test, because that problem is definitely there because it's a molecular problem.
Anything around parasite density for the different in the spectrum of diagnosis, how much the malaria was as opposed to just having malaria? Did you look at that
Yeah,
spectrum?
we just got the data. We are still in that process. So we're looking at the parasite load, which actually,
Parasite load, yeah.
yeah, the TrueNat actually gives us a value, and we want to compare it with the peripheral smears positivity and the index also. So we have to do that analysis. It's
Okay.
still, yeah, that would be very
Quantitative versus
interesting. Yes,
qualitative.
yes.
Fantastic. Thank you.
Yeah.
Maybe a related question. What's the type of test that India needs? So India, very much different from Uganda, is going into their elimination program. So what is that type of test? So what would be, that would be the target product that we want. So India is aggressively going into a malaria elimination campaign. A very different from Uganda. Right. So what are the benchmarks of that test that you want that India will need to do rapid diagnosis? Just to fill us in the two tests.
Yeah, so I don't think we have such a good focus to think that what is the best test as of now. So what we are seeing is, disappearance, resurgence, disappearance, resurgence. We had very good, control till a few years back, but this year we were really seeing a resurgence. So there is something which is happening. Probably we are not really looking at submicroscopic malaria. And, the RTT is not performing as well as the PS that we obviously knew. So there is a gap which we need to fill in using probably tests which are more accurate in picking up these submicroscopic ones if we are looking towards elimination. And the beauty of TrueNat is that it is already deployed for TB, and it was deployed for COVID also. So these instruments are available in all the centers that we can deploy this test, and so it is definitely a potential to be.